Alright, today we're going to be learning about how to add and subtract rational expressions and how to simplify complex fractions. To add or subtract rational expressions, you're going to first factor to find a common denominator. Then get all terms to have the common denominator. Add or subtract the numerators. And finally simplify. In the first three, they already have the same denominator, so we can jump down to step 3. So when we add or subtract the numerators, we get 16. The denominator is going to stay the same, and then simplify in the fraction. 16 over 4 would be 4, and the x stays in the denominator. Since we have x in the denominator, our domain is x such that x cannot equal 0. In number 2, our common denominator is x plus 1, so for our domain we know that x cannot equal -1. When we add our numerators together, 5 plus x is just x plus 5, and our denominator stays x plus 1. In number 3, our denominator is x minus 3, so we know our domain x cannot equal 3. And this time we need to pay attention that we're subtracting, so it's 2x minus 1 as the numerator and x minus 3 as the denominator. Next, we're going to practice with finding the least common denominator. So in order to do that, the first thing we need to do is factor all the denominators. There's nothing to factor with x minus 1, and we factor x squared minus 1. That factors to x minus 1 times x plus 1. They both have x minus 1, so that needs to be in our common denominator. And then, because this fraction has an x plus 1 also, that also needs to be in our least common denominator. In example number 5, the denominators are already factored, but just a reminder, this means 2 times x, and this means 2 times x plus 1 times x plus 1. So, since they all have a 2, we know that needs to be in our LCD. This first one also wants there to be an x plus 1, which takes care of that x plus 1. This denominator also wants there to be just a single x. And then this denominator wants us to have an additional x plus 1. This could also be written as 2x times x plus 1 squared. So each piece of every denominator needs to be in there. It only needs to be repeated if it's in one denominator twice. Alright, so let's move on to some full problems we're going to completely add and subtract. So, first thing we need to do is factor to find the least common denominator. Here, they're both already factored and they have nothing in common, so our LCD is just putting the two factors together. For each fraction, we're going to multiply top and bottom by the factor that it's missing from the LCD. So this one already has the x plus 5. It needs the x plus 1, so we multiply it on the bottom, and we multiply it on the top. This fraction's missing the x plus 5, so we multiply it on the top and on the bottom. Our LCD is what we're going to look at for our domain. So for this one, x cannot equal -5 and -1. Next thing we need to do is distribute in our numerators. So we get 3x plus 3 plus 4x plus 20 all over our LCD. And then combine like terms in our numerator. And we're finished because 7x and 23 don't have anything in common to factor out. So number 7, we're going to factor this denominator first. This denominator can't be factored. For our LCD, this one wants both of those factors. This denominator is part of those factors, so we don't need to write it again. Now, there's actually something that we can do in this one to make our problem shorter. If you notice, there's an x minus 3 on the top and an x minus 3 on the bottom. And hopefully you remember from last class that we can cancel those out. And that will leave us with just a 1 on the top. Now for our domain, that's always going to be based off the least common denominator. So we know that x cannot equal plus or minus 3. Here, since these canceled, we have 1 over x plus 3 plus 7 over x plus 3, and that equals 8 over x plus 3. Let's try another one.
Interruption, I need to announce back to the students to lab 2103 for testing. The following students, please immediately to lab 2103.
No, I just paused it.
You sure?
Yeah. Here, the 6, its denominator will just be over 1, which means our LCD is just x plus 3. The first fraction's missing x plus 3, so multiply it on top and on the bottom. Because it's minus here, to make it a little bit easier, I'm going to change it to plus and make this a -5 so that I don't forget about it. For our domain, we know that x cannot equal -3. And our numerators distribute on the top. And then -5 over x plus 3. Then we're going to combine like terms, 6x plus 13 over x plus 3. There's nothing in common in the numerator to factor, so that's our final answer. And number 9, our LCD would be 2x squared. The 2 from here, the x squared from here, and technically x is part of x squared because x squared is x times x. So in order to go from 2 to x squared, from 2 to 2x squared, we're going to multiply by x squared. To go from x to 2x squared, we need to multiply by 2x. And to go from x squared to 2x squared, we need to multiply by 2. Don't forget to write your domain here because of it just has an x squared. X cannot equal 0. And then simplify all your numerators. X squared plus 4x minus 6 all over 2x squared. The numerator again can't be factored, so we're done. All right, one more example on adding and subtracting. This is already factored. This is already factored. This denominator would factor to x minus 6 and x plus 1. So our domain would be x such that x cannot equal negative 1 or positive 6. Our LCD would be x minus 6 and x plus 1. So we're going to multiply each term by what it's missing. So our first term is missing the x minus 6. Our second term is missing the x plus 1. And the thing we need to be careful about with the third term is the minus here needs to get distributed to both terms. So we'll distribute there, and distribute here. So we would end up with x minus 6 plus x squared plus x minus 5x plus 2 all over x minus 6 and x plus 1. Combine like terms in our numerator. We end up with x squared, x plus x, which is 2x, minus 5x is minus 3x. Negative 6 and positive 2 would be minus 4 over x minus 6 times x plus 1. This numerator can be factored. It factors to x minus 4 and x plus 1. Denominator stays the same. And look, we have the same factor on top and the same factor on the bottom, so those cancel out. So our final answer is x minus 4 over x minus 6. Our last type of problem are called complex fractions. They're fractions within a fraction. So what we need to do is look at the denominator of each term. So 2, 1 over x, x over 1. Here, our LCD would be x. So what we're going to do is we're going to multiply each term by the x. Based on our LCD, we know that our domain cannot equal 0. And when we're finished, we might have to add some more to this. So x times 2 would be 2x minus, here we have an x on the bottom, an x on top, so those will cancel out. So we'll just have minus 1 over x times x is x squared. Our new denominator is just x squared, so that means x can't equal 0, which we already had in our domain. So our domain didn't have to change, and that's our simplified complex fraction. So number 12, we've got 3 denominators, x plus 3, x minus 3, and x squared minus 9. We know that factors to x plus 3 and x minus 3, which means our LCD is x plus 3 and x minus 3. So multiply all 3 terms by the LCD. So in our numerator, the x plus 3's cancel out, and 1 times x minus 3 would be x minus 3. In our denominator, in our fraction on the left, the x minus 3's cancel out. X plus 3 times 2 would be 2x plus 6. And then on our fraction on the right, the whole thing cancels out. So we'd be left with minus 7. Combine like terms, we get x minus 3 over 2x minus 1. For our domain, we need our domain restrictions from our LCD, which would be plus or minus 3. And then we also need the domain restriction from our the denominator of our final answer, which would be 1/2. That's all for today.